What if I told you that reality, as you know it, is not as straightforward as it seems? That the fundamental particles of the universe behave in ways that defy our everyday intuition? Welcome to the quantum world, where the rules of classical physics take a back seat, and particles like electrons and photons play by a different set of rules. First and foremost, let's delve into the concept of wave-particle duality. In the quantum realm, particles such as electrons and photons exhibit both wave-like and particle-like properties. This is called wave-particle duality. The behavior of these particles is described by wave functions, which represent the probability of finding a particle in a specific state. So, an electron, for example, behaves like a particle and a wave simultaneously. Mind-bending, isn't it? Next up is quantum superposition. In the quantum world, systems can exist in multiple states simultaneously. This is known as superposition. Imagine an electron existing in multiple positions at the same time until someone decides to measure or observe it. It's as if reality doesn't commit until it absolutely has to. Moving on to quantum entanglement, a phenomenon that baffled even Einstein, who famously referred to it as spooky action at a distance. When two or more particles become entangled, the state of one particle becomes directly related to the state of the other, no matter how far apart they are. Yes, you heard it right. Changes to one particle will instantaneously affect the other, even if they are light years apart. Then there's the quantum uncertainty principle, as formulated by Werner Heisenberg. This principle states that it is impossible to simultaneously know both the exact position and momentum of a particle. The more accurately you know one of these properties, the less accurately you can know the other. It's as if the universe is telling us that some things are meant to remain uncertain. Quantum tunneling is another fascinating concept. It says that particles can pass through energy barriers that classical physics would consider impenetrable. It's like walking through walls, but for particles. This concept is not just theoretical. It has practical applications in technologies like tunnel diodes and scanning tunneling microscopes. Finally, there comes the quantum measurement problem. The act of measuring a quantum system has some interesting implications. It causes the system to collapse into one of its possible states, changing the probabilities of its properties. It's as if the very act of observing alters what is being observed. So to wrap it up, the quantum world is full of phenomena that challenge our understanding of reality. Wave-particle duality, quantum superposition, quantum entanglement, the quantum uncertainty principle, quantum tunneling, and the quantum measurement problem. These are the key concepts that underpin the enigmatic and fascinating world of quantum physics. A world where particles can be in two places at once, where they can pass through impenetrable barriers, and where they can instantaneously affect each other over vast distances. It's a world that is as intriguing as it is perplexing, and it's waiting for us to explore its depths. So buckle up and get ready for a mind-bending journey into the heart of the quantum world.